Hello everybody, this is SF Scala Developer Series. Today we are doing a meetup at Nitro with Chris Yang and Nick Elprin of Domino Labs.
Hey Alexy, thanks for having us.
Great to have you guys. And they are actually using Scala to power their cloud-hosted data science website, where data scientists can upload the code and run it in the cloud and share and interact around this. And they're using Scala to actually make this technology. And the topic of today's meetup is Scala Notebook, which is interactive REPL in the browser, where you can enter your code and look at it interactively, much like Mathematica or IPython, but powered by Scala. And Chris was one of the original authors of Scala Notebook. So I want to ask you, Chris, can you tell us about the genesis of that project, how it came about, what's the history behind it?
Yeah, sure. So Scala Notebook was a project that I worked on when Nick and I were both at Bridgewater Associates, which is a big sort of financial institution in Connecticut. And so what was going on there was that we were interested in developing an interactive environment where we could use Scala to do analysis, analytical type work. And so we looked out across the current art, and the best we sort of saw was IPython Notebook. There were some rather undeveloped sort of backends for Scala, and so we wanted to see what we could do in sort of like a 6 weeks skunkworks project to see if we could swap out the backend of IPython Notebook and make it sort of Scala based all the way through. And so we forked the IPython Notebook front ends. We replaced the back end with Scala, and there were some features about interactivity that we'll be showing off and talking about tonight that were of particular interest for us. So it wasn't just that you could run Scala code. That's obviously very important, but we were particularly interested in developing some more interactivity, so the ability to actuate things in the HTML and have that propagate back to the Scala backend and actually have Scala code run as a result of that. So it was pretty exciting stuff. So Bridgewater open sourced it, I think, a year and a half ago or something like that. And in that time, Nick and I both left Bridgewater sort of for our own reasons, but we still contribute back to Scala Notebook because it was sort of a fun project and sort of a neat thing. And it's been cool to see how the notebook environment has developed over that time to create a lot of feature parity in a lot of the stuff that we were interested in. So in particular, IPython Notebook has added a lot of interactivity, I think, in their version 2, and in the meantime, a lot of other notebook projects have sprung up as well, and so it's been a pretty exciting space to be a part of.
Great. So I'm curious about the environment in Bridgewater, which was conducive to make this kind of project, because we usually associate Wall Street with frenzy and stress and high frequency trading and all these kind of things. So, but it's not the first project which I see coming out of Bridgewater and others, which I think they also do some interesting stuff with F# and data frames in R. So I've seen a lot of interest in open source coming out of it. And what is it typical for Wall Street firms, or was it, what was it about Bridgewater? And I guess what is kind of the motivation there to have these kind of tools in the first place?
Sure, yeah. I think I certainly can't speak for Bridgewater now. It's been a little while since I've worked there, but from what we've seen in sort of finance broadly and in other sort of other high technology places that are really using technology to sort of deliver value to whatever business they're in, I think there's an increasing recognition of the power of open source, both as a way to get more eyes on a problem, potentially get some engineering talent, as a way to contribute back to the community. Like, so many places are powered by open source tools, and so there's definitely a sense that in these places they should be contributing back. And hopefully it doesn't sound too cynical, but as a recruiting or a way to sort of get your name out, that makes those places an attractive place to work.
Yeah, I think there's a recognition that financial firms aren't only competing with other financial firms, they're also competing with all other firms for talent. And so making it clear to the world that this place is a place where exciting, interesting technology happens, draws the best people in.
Great. So they actually piggyback on the same strategy startups are using to open source these tools, which kind of segues me into the Domino. So you guys are building Domino. Can you tell me a little bit about what it is, what is the motivation, who are the potential users, and how it differs from the current other offerings in the data science?
And I got this out of the way. Yeah, so the central observation I think we had is that so everyone knows the world is becoming more analytical, and I think what we're seeing is it's no longer enough for firms to just point a visualization tool at a database. It's not just about querying data and visualizing it anymore. It's about running code on top of that, developing models, whatever you want to call them, these more sophisticated analytical projects. And we basically saw from the companies we talked to that there was a piece of the tech stack that was missing to really facilitate that at scale within an enterprise that would do things like let you visualize the results that you'd produced from running this code, be it in Python or R or Scala or whatever, do version control properly for data science, which meant tracking not just your code, but tracking the data you used and the results that you generated, making all that available and accessible and shareable. So that's the gap we're trying to fill with Domino. It's sort of a central hub for analytics within the enterprise that facilitates sharing, tracking, scaling, collaborating, and ultimately deploying or productionizing or operationalizing models so that they can actually integrate with other business processes. So that sort of end-to-end analytical life cycle.
This is great. So what kind of thinking have you been going with when you chose Scala? Like what are the other options? How is it working out for you? Can you talk a little bit about that?
In case it wasn't obvious, Domino is written sort of from the ground up to be Scala. It's a play application. Sort of 90% of the code there is Scala, and so the decision for us, I think, was pretty clear. Scala is a modern, powerful language that we were familiar with from our past experience in a production context, and so just to drive that point home a little bit, it's one thing to be able to write hello world in Ruby. It's quite another thing when you're up your third straight night with a Java debugger attached to a JVM trying to track down a crazy deadlocking thing. And so the power of Scala as a language was as important to us as the power, richness, and flexibility of the whole JVM ecosystem that allows us to build like an actual system that can actually stay up, that we can actually debug. And so the maturity of the JVM combined with the power expressivity of Scala itself, I think just was a total slam dunk for us. I don't regret it at all. I mean, I think it's been a great experience for us in terms of just the Scala language itself. Like we make heavy use of akka functional paradigms, and so Scala's been a great match for how we've thought about engineering our stack.
Which is, I mean, and as a result, I think the code base has remained no bigger than it needed to be. Like so it's efficiently expressed, and that's let us scale our development by bringing on contractors pretty easily. People, kind of everyone we've brought in has had a very easy time getting up to speed with the code base, which is better for us because it means they can contribute faster. So I think it's paid off.
I wonder, do we have any reflections on what it's been like to try and hire Scala developers? Like, what's the state of the market in terms of like Scala talent? I mean, I think thinking back of like all the interviews we've had and resumes that we've screened, the Scala development community is definitely smaller than, say, like the Java community, but
Probably for the better too.
Probably for the better. There's some self-selection, and so the skill, abilities, maturity of the candidates that we do see that are sort of like people that are interested in working in Scala has been sort of much higher than.
Though there is one sort of anti-pattern of, I think it's like engineers who are attracted to Scala and excited about it for a lot of the more esoteric features, and so they get excited about a language for its features rather than, and sort of like finding opportunities to use those features rather than using them as tools to write well-engineered code.
Yeah, that's true. Yeah.
Because there's Scala gives you a lot of rope, which can be used to hang yourself, sort of, and so that's one of the things we look for when we talk to candidates. Is just because that feature in the language is there, does that mean you have to use it? When would you actually use it?
Mm-hmm. Well, we've all been there. I think the first time you learn about implicit conversions, you're like, oh man, everything should be implicitly converted from one thing to another. And then you sort of, within 6 weeks, you sort of realize what a terrible, terrible idea that is. So, but yeah, I think I definitely agree with that. Yeah, that makes sense to me.
Great. So maybe I'll ask you to talk a bit about a data science community. And actually, I have, I guess, two questions, because I think in addition to Scala, we also share Galvanize as a location where you guys are working from. And I recently joined the advisory board, and I really believe that this kind of techno-social community where you have a lot of virtual communities centered around data science and kind of physical presence around meetups and conferences is a great idea. Also, education programs, and we'll have 3 conferences this year: Text by the Bay, Scala by the Bay, and Big Data Scala hosted at Galvanize. And Big Data Scala is actually about end-to-end data pipelines in Scala and data science on Scala. So I wonder, what are you thinking in terms of community building through Domino, which is in the cloud, and kind of how do you connect to data scientists around you at Galvanize, and like, is there any kind of analogies you can draw between how real-life collaboration happens versus these cloud-based collaborations which you are envisioning and building?
Yeah, let me think about that for 1 sec. Well, one thing to clarify, by the way, is we have the demo we'll do is of kind of the cloud-hosted version of our product, but there's a parallel deployment option where the whole thing installs on premise, and so a number of our customers who are more concerned about data security and don't want things leaving their network can sort of still use our stack behind their firewall. But, yeah. But in terms of the community, well, one interesting thing we've seen is that there's enthusiasm for an idea like GitHub for analytics in the world, GitHub for analytical projects. We haven't seen that play out that much, and I think part of the reason is that so much of it depends on the data, which is often proprietary and inherently not shareable. It's shareable within teams, but the idea of something more analogous to GitHub, where you have these massive projects that are done at scale across the world, I think you run into a tension where there's something so proprietary to somebody, a company or a government agency or whatever, that it's hard to actually effectively implement that. So I think the opportunity for community is much more around, like you're saying, meetups and cross-pollination of ideas and knowledge and new technologies. I'm not, I think it would be a beautiful world to live in where there was something like a worldwide GitHub, massive collaboration on analytical projects. But I think somebody will have to crack the nut of how do you share the data necessary to do that. And I don't mean in a technical way. I mean, what are around just the proprietary nature of it, the legalities around it.
Privacy.
Yeah. We know. Well, obviously, there's interesting. We work with companies doing interesting analytical work, and they wouldn't release their data. But then there are interesting projects that we know about that you'd think would be good candidates for it, like people in academia working on these analyses. But what you find there is that a lot of the data they have is proprietary data from certain vendors, like Nielsen or some government agency that that they're under by contract not allowed to share with anyone else. So that'll be nice to figure that out.
I can actually propose one solution. So we at Nitro are thinking hard about sharing a lot of open source code around data problems we have, which is in the document space. So we are building smart documents, which are basically PDFs where we can understand both their internal structure and human intent behind them and the social graph where they're shared. So one thing we've done, we are securing scientific literature, such as CiteSeer or archive.org, and this data which is already open can be a model, right? So we can test a lot of algorithms and run a lot of extraction tasks on the public documents, and then apply techniques learned to the private documents. So I think one way to share code around data would be to share some common data sets, such as network price, right? And what Kaggle is doing. So hopefully that can be one way. But another thing, you may have a large organization which will be behind the firewall, and then those data scientists may actually collaborate through the private cloud, right? And so I think, like in my mind, that may be one big advantage. So do you think of any features such as commenting, sharing, and annotation of the code which people upload to Domino? What is your kind of vision around this?
Well, I think one of the sort of core beliefs we've built into the product is, if you talk about version control and sharing for source code, really all you need is the source code. But if you talk about doing it for analytical work, what you need is the code, the data, and the results kind of connected together. And by the results, I mean charts that you produce, or models that you generate, or model performance scores. Because if you're looking at your progress and you want to say how is this analysis evolving, those are the metrics by which you evaluate your progress. So, I mean, the way we think about it is your code and your data together produce these results, and then that is a unit that evolves over time. And so when you talk about collaboration, what's useful is a linkage between those things, and commenting both at somewhat at the level of the code, but also at the level of the results. Here's a performance graph we generated showing prediction scores. I noticed something that changed. I want to circle that, and then I want that comment or question to be connected to what was the change in the code of the model that led to the difference in results. So the analogy in source code would be something like tracking the binaries associated with each build of your code. But with analysis, the results are much more visual.
Interesting. So that I'd like to see all of that. That will be a great tool for collaboration. And one question which is common to Scala data scientists is, how good is Scala a platform for data science? How good is JVM a platform for data science? And you actually provide a lot of functionality to Python people, right? So you straddle the worlds. So I wonder, what are your insights around this? What can we tell Python people, about the state of Scala for data science? How can we invite them to the Scala world? What should we as a Scala community do to make it easier for them to come to the Scala world for data science?
Try and fill this one. I think projects like Spark have been pretty exciting to see as they've developed. I'm looking forward to the demo I think you guys are going to be doing about how you're using it internally. I think there is something interesting, at least from what we've seen. The data scientists that are using Scala tend to be at the even highest end in terms of sophistication. Like, I think everyone that we know that uses Scala that way, was an ex software engineer, or could have been in another life, if that's, how their interests went earlier on. And so what's interesting, at least in the state of the market now, is sort of this conflation between language choice and sort of technical acumen. And I don't know if there's a causal relationship, you need to be this amount of smart to establish this. Sure, yeah, we can try and and so I think that'll be interesting. I mean, that's a hypothesis that I have about the space. It could be that for whatever reason, Scala is just a more difficult thing to go learn, in which case it's not clear how much extra tooling you would need. I'm not sure what my opinion about that is, but that could explain some of the gaps between Python data science and Scala data science. I would say that in terms of the actual literal tools and the actual literal libraries, I think that JVM ecosystem is probably a couple years behind. There isn't a standardized data frame type thing. There isn't a standardized NumPy, SciPy. And it's not that there aren't equivalent bits of functionality in the JVM scattered across 1,000 different Maven repositories. Is that there hasn't been a consensus coalesced around harnessing everyone saying like, hey, this is the matrix library everyone's going to use, like everyone contribute to it. And so it makes it hard to get started. It makes it hard to, I think, iterate and have those things improve release on release, patch on patch. And so I know a lot of people are trying to do this. I think we were just looking at what were we looking at? Something connected to deep learning, I think, like DL4J.
And D4J.
Yeah. Yeah. And so I think there's some evidence that that's getting some traction, but I would love to know how the arc of adoption of NumPy, SciPy, and Pandas like actually started, and if there are lessons from the adoption and coalescence around those libraries, if there's some lessons that we could apply at the JVM.
Great. I think there are some good news there. I've seen the Databricks roadmap for this year, and they standardize on schema RDD, actually the data frame format, and they want to interface it with Pandas and other libraries. And I think they actually putting this forward not just for Spark SQL, but as a general interchange format. And so that hopefully will have a distributed data frame, which is probably hard to have in our Python or other languages. And in terms of linear algebra, I think there are several good libraries. There is Breeze, there is ND4J, there is LA4J from Twitter, but it's really a good question, for the community to basically rally behind one of them and create a lot of tools, a lot of documentation, and kind of socialize that set as a good library.
If anyone can do it, it's probably Databricks/Apache to just say like, hey guys, this is how it's going to go. So yeah, I hope that works. That'd be totally awesome if there's some standard interop, especially some interop with Python and other framey type things. That'd be pretty cool, actually. So.
Yeah, let's hope so. And of course, we'll have several tracks at Big Data Scala in August to kind of help the community to focus on these issues. So I think in closing, I'd like to ask you guys, what is your vision for Domino in 1 to 3 years? And we'll come back and chat with you then. Of course, we'll do this before as well, but it would be great to kind of compare predictions and in the future at some point. So I'd like to see your vision as founders. How it's gonna go.
You want to take a shot?
Why don't you go first?
You go first.
I'm gonna draft off of your answer, I think.
Well, the goal we're pursuing, or the mission we have, is to empower this new wave of more powerful analytical techniques. And so, be that machine learning, or be that just much more sophisticated, computations to better do anything within an enterprise. It's this idea that more and more businesses are running their business not on data, but on analysis. And so I think that means a bunch of different things. I think that means better compounding of knowledge and people being able to leverage the ongoing work that other people within their organization are doing. I think it means reducing the time to test an idea once you have a thought for it, so reducing the ratio of thinking to doing time or something like that. I think it also means making it more fluid to take a model that you've built and deploy it so that it actually affects things in your business, that it's not just an analyst who runs something on their machine when somebody asks them for an answer, but it is seamlessly integrated into the operations of the business itself. So I think it's all those things that we're pursuing, and that's the way I think about how we prioritize the different features we develop. So that's the level at which we hold the vision. It's not a level of, the product will have these features and will look like X, Y, and Z, but it's whatever the most sophisticated companies you need in order to make these powerful analytical techniques really drive the actual core work of the business they're doing.
Sounds like a great plan. Chris, do you have anything to this?
I think I may have successfully drafted off your answer by just saying, Nick, I think that was a great articulation of our vision. So I think no more words are necessary.
All right.
Great. Thanks, guys, for sharing these insights. And we're looking forward to your talks tonight. And great to have you in the community.
Thanks, Alexy.
Thanks so much.
Thanks.